Hello, today I'm going to make a video about how to Canadian compile GCC. Now, you might ask, why do we need to Canadian compile GCC? Okay, what is Canadian compile and what is for, right? So think of it. If you are running on a platform that does not have GCC, okay, like Windows, for example, right? Or your own operating system, your own architecture. You want to port GCC to your platform that does not contain a GCC. It might not contain GCC for a lot of reasons. For example, it just simply doesn't have the installation of GCC, right? Now you might say, I can just copy one of them, but copying one of them might not work due to all sorts of reasons, right? Because of that, we wanna just get GCC on another machine, right? So another problem why it's in a situation is that your computer is capable of installing a GCC, but you want to install a new version of GCC, right? You don't want the old version of GCC, you want a new version of GCC. Although you have the old versions of GCC that can compile a new version, the machine might be very, very slow. Like this Raspberry Pi I have here, right? It's very slow, right? If you compile GCC, it's going to take you 6 hours probably just to compile, to get a new version of GCC installed. Those are issues we want to address here. Now you might say, I can just do simple apt-get install build essential. It will give me all the package I need, right? However, the problem is that usually you won't get the latest installation from the repository, right? Because they only build every release, whatever. You're not going to get the master version of GCC, which is today's GCC 12. GCC 12 has been around 6 months or 8 months, but you are still using GCC 11 or probably GCC 10. Some people are starting using GCC 6, whatever. When we need to get, we want that machine to get a new version of GCC, right? You might not have a very old version or just very slow or a lot of reasons. Or you just build very, very old versions of GCC. For example, it has GCC 4.1. That will not compile the new version of GCC because GCC now requires you at least GCC 4.9, 4.9.2 to build new versions of GCC, right? It requires C++ 11 standard right now. Okay, so because of all sorts of reasons, you might not be able to just use the old version of GCC to get a new version of GCC, right? So the reason we want to do Canadian compilation are two reasons. Okay, two kinds of reasons is that first, the platform itself does not have a GCC. Second, it has a GCC, but it is very old. Okay, the version is very old. Okay, the version is very old. Okay, or it has a GCC, but the machine itself is very slow. Okay, we have a low computing power machine. I cannot build new versions. Okay, so first, the platform itself does not have a GCC. You know, a lot of people think if I have a new architecture, let's just assume we don't have our RISC-V, okay, RISC-V architecture. Oh, we don't have GCC on that architecture. We want to port our GCC to that platform. You might think I would just manually do bootstrapping from an old version and old versions of GCC to compile a new version of GCC. You compile KRC, manually compile C compiler, then using the KRC to compile an old version of GCC, an old version of GCC to manually bootstrap one step, right? That's not how the thing works, okay? It never be the thing work. And even you do that, you will not be able to get that. Because you need first to add all sorts of things to GCC backend to let GCC understand you have the risk file, right? You also need to do something. Or how could you know how to do that? And second, this step is totally a waste of time, right? You need to manually write papers, translate C code on paper to get a compiler. You're just repeating the work. This is nonsense, right? A lot of these things that way. If I don't have an old version of GCC, I would just manually bootstrap it from that. That is not the thing work, okay? The thing is that we are going to talk about today is to do Canadian compilation. So what is Canadian compilation? The source of Canadian compilation is that we use native compiler to build a cross compiler. Okay, we use a very high computing power of machine, and with a very new version of GCC, use that machine to compile the compiler for them another machine. Okay, so we use native compiler to build a cross compiler. Then use this cross compiler to build the GCC we need on that machine. Okay, so we're gonna explain that by details. But before we're doing that, we need to first understand how to do native compilation. I think a lot of people, they simply don't know how to do native compilation. If you don't know how to do Canadian compile a GCC, how can you do cross compiler? How to create a cross compiler? How do you create a Canadian compiler? You cannot do that, right? So first we need to do is that we need to manually do this. We need to clone two products. One is BingUtils GDB, because BingUtils GDB provides assembler, linker, and obj DOM, all sorts of tools, plus GDB, okay? Compiler needs linker, assembler to compile, right? You cannot just compile things. That's what we call toolchain. It's not just compiler. It's called toolchains because it does not just contain the compiler itself. It also compiles the supporting libraries and the linker assembler, and all sorts of other binary tools. This is called binary BingUtils, right? So I am strongly not recommending you for using Windows. No sequencing, no mistakes. There was time. Of course, not recommending you for using WSL. Okay, not recommending you for using. I should not recommend using virtual machine. Okay, so please do not install virtual machine and do the compilation inside virtual machine. Usually it doesn't have enough memory. You won't be able to compile. It requires a lot of memory. Okay, so please find a fastest machine you can, and do not use any virtual machine. And not using Windows. Okay. Okay. If you just do native compilation on Linux, you don't need fixed password. We are going to fix password later. Okay. So the whole thing is here. Okay. So we first need to upgrade our GCC. No matter what your GCC version is, you need to. We're using Ubuntu as an example. If you're using Arch Linux or other Linux, please, you need to learn how to do that in the Sanitizers machine. You need to install GCC. You also need to make whatever all sorts of computing tools, plus Python and Flash. So we install all those things, and just assume you have done that. I don't waste time on it. Then we need to clone the project here, clone GCC and BingUtils here. So we go here, we go to that repository. We can see here's the URL here. Now we just clone it from it. Okay, I've already clone it. Okay, I've already clone it. I'm just not going to waste time. So we need to do something here. So you need to go here, go to the row CXX for target. Okay, this is a bug. I think it will be fixed in the future, several months later. But in GCC 11 and GCC 12, we have this bug, row CXX for target, which means we need to add this no std in C++ here. Okay, I've done that. I'm not going to waste time. And we are going to start the compile here. So what we do is we create a folder called GCC build, and we create several folders here. We create a folder called native. Okay. Now, first thing we need to do is that we need to upgrade our GCC and Bing utils. Okay. You can first choose using GCC or Bing. It doesn't matter here, but it matters in future. You also always need to first build Bing utils GDB before building GCC. So here we got upgrade. We first build Bing utils GDB to upgrade our Bing utils. So we go here, and since we Bing utils cloning my home directory, then we just do this. We first need to do how to do native compilation. We need to disable NARS and WError. Always do that, okay? Then we need with Python 3. Now you might say, why do we need with Python 3? Is that if you want to debugging with Python, you need to install Python 3 with Python 3 here. Or you won't be able to show the contents in the C++ containers. You probably want to show contents in the vector arrays, whatever, map, whatever, right? Now we also need to enable Gold. Enable Gold linker. Okay, so Bing utils GDB provide two linkers. One is the LD, which is default use. The other is Gold linker, which is for ELF only. It doesn't work for PE. It works for ELF. We need to use this too. Okay, with that we press enter. All right. Okay. The reason is that Bing utils GDB. We don't have the fourth directory. Probably I did not compile it. Okay. I do have that, right? Native. Okay, we need to cd. Oh, the reason is that it tells us this directory. So it is Bing utils GDB config here. Okay. I'm going to copy this here because a lot of people are not willing to manually type this. Okay. And after that, we do pour it. Okay, git pour. If you think your version is not new enough, you need git pour here. Make J. Okay, don't build it directly in the Bing utils directory. Okay, create another directory above that. Create some subdirectory to manually go to the config file. Okay, don't mess things up. So that we make J. So let me be very, very fast. This machine is very, very fast. I think around 30 seconds, probably going to finish this step. And almost a minute, I think. Okay. I'm not going to switch to other thing here. So this step is building a new linker and assembler for your native machine. Okay, on this very powerful machine, right? If your native versions of GCC are slow, are very old, I think you probably need to first build GCC, then build BingUtils. I'm gonna talk later. But usually we first build BingUtils. Oh, it's slower than I thought. Probably native compilation would take more time than cross and Canadian. Canadian is very fast. Here's a lot of warnings in the BingUtils and GCC here. Right. We might be able to encounter any bugs. If we encounter any bugs, please find a bug report to the BingUtils or GCC. Gold, okay? Gold linker. Okay, that's done. Then we do sudo mace install strip. Install strip. The difference between install and install strip is that install strip will strip your binary. Will not just install, it also strip your binary. You don't want a large binary here. You don't want any debugging information, so we make install strip. Then type our password. Okay, native compilation need to pass our password because it's installed on your machine, right? Now we have a new version of linker or GDB, whatever. We can just check that by using GDB. Okay, we can just type GDB. It tells us our version is today's version, right? Today's basically New Year. Oh, I forgot to say Happy New Year. Okay, whatever. So then we go to GCC. We do the same thing as what BingUtils does, but we need to add some more things here. Okay. We don't with Python 3 because it doesn't do anything with Python, right? So we need to disable. No, we need to disable Bootstrap. If you're doing native compilation, the GCC will by default enable Bootstrap. Okay, Bootstrap is not something what we want. We don't want to compile that for 3 times. That's going to waste your time because GCC is going to compile 3 times. So please disable Bootstrap here. Then we need to, okay, I think I have previous installation. I can just use that. Okay, I'm going to expand on that later. Then we need to enable languages C and C++. If you have already installed G++ multilib, GCC multilib, you should install that. With the multilib, you can also install with the multilib list, right? So we have M64, M32, and MX32 on Linux. Okay, on our x86 64 Linux, which is compiled for 64-bit Linux. 32 means Linux, and X32 is that they will use the more registers. Okay, using all the registers are 64, but the computation with the pointers that we are still using 32, okay, which probably going to be faster on some situation like 64 here. That's why you have MX32 here. On PE, you don't have that kind of things. Okay, if you don't want to understand it, you can go CSV, whatever, Itanium, ABI, whatever. Okay, you could go to see that. The WAF, right? The WAF. Then we also need to enable multilib. Okay, enable multilib and enable languages C and C++, right? We don't need any other languages. We don't want to waste time on building other languages. We enable multilib, and you can get a PKG version. You can see here I have my CQ here. You can just put PKG here, then it will show something here. Then with multilib list, okay, Okay, we can put that here. It doesn't matter. This tower doesn't matter. Okay, you put it whatever you want, and then you can even not put that. Not put that. You would just show GCC. I'm not going to put it here. I'm not going to get anything here. Okay, I'll give it a version, right? Okay, give it one. I'll give Happy New Year, right? Okay, 2022. Then it's done. If you're going to using the lib LLVM libc access, we know LLVM also provide the libc++. We can also add this in here. Not here. We can just compile. Okay, put it here with your libc++ installation. It should be just installed at USR local include C++, C++v1 by default. If you're using the CMake build system with libc. Okay, so that's all the things we need. Okay, there's another thing we need to disable here. Is this disable libstdc++ verbals. Okay. Okay. No, we're going to just do this. Okay, always check build host target, whether it's the target you want to do, and then ensure you have Bison flags, all sorts of things that is installed. Now we go make J here. Okay, it will take around 5 to 10 minutes. So I'm going to explain things by using that time. So after we have the native compiler, we're going to use this new versions of G++ to do a cross compile of G++. Okay. For example, if we want to compile on Raspberry Pi, for example, on this Raspberry Pi, okay, it's on ARC64, which is ARM64. Then we need to do is that we need to use this ARC64 Linux G++. We need to create a cross compiler of ARC64 Linux GNU G++ and use this cross compiler to compile the compiler itself, right? Now it might be a little confusing here. Is that first we need to build a cross compiler, right? The cross compiler produce binary on that machine, on this Raspberry Pi machine, right? On this ARM64 Raspberry Pi machine. Then if we use this this cross compiler to compile GCC itself, we get the GCC that runs on that machine, right? On this Raspberry Pi. Okay. Using cross compiler to compile the compiler itself, produce a compiler that works on another machine, on this machine. Okay, we can also do using this x86 W64 MinGW machine to create that compiler. Then use that cross compiler, compile GCC and big util, whatever, all sorts of things themselves. We get a G++ that runs on Windows. Okay, runs on Windows. For example, on this machine, I have a GCC installed. That is by using cross compilation, or Canadian compilation. So we are going to show that today. Now you might say, what if I'm using these two toolchains together? Okay, plus the native G++. Okay, because you also need some native tools that will produce binaries on this machine for build. If you have 3 machines, then we will get a cross compiler running on Windows. All you can do, the reversing, is that you have Windows cross compile Windows things on Raspberry Pi, which is you can compile Raspberry Pi program on Windows, or compile Windows program on the Raspberry Pi. Okay, it's confusing here. So now you might say, how does that work? what that will things work is that now GCC will use this, for example, on this example, it will use x86-64 to x86-64 W64 min GW G++ cross compiler to build this cross compiler, the compiler part of that compiler and linker part. Then use ARC64 Linux G++ to build the library part of GCC. Okay, it's confusing. Just think more. Okay. I think. Okay, it's still compiler. We don't care. Let me explain again. We're going to have a GCC by using cross compiler. This cross compiler to cross compile the compiler itself, and then use this compiler, cross compiler, to build the library. Then use native GCC to build something for the build system. Okay, which is why they call three things called host, build, host, target. Okay, we just see that, right, with the build here. We can see the build. I'm just check here. You can see it before you have build, host, target, right? So it's a little bit weird when you first do that, but you think of it, it does make sense, right? Okay, it works like magic, right? How do you do that? So let's see another situation. If I just use native G++ plus cross compiler G++, right? What are we going to do with it? We combine them together. Okay. Then we can actually get a cross compiler that can cross back to the machine we are running, we are building here. We'll build here. So this is called cross back compilation. Okay. But it's also part of Canadian compilation, just a special kind of Canadian compilation. It's called cross back. It's that we compile the code that can compile back to the machine we are running here. Okay. So that's how the things work here. But before we do Canadian compilation, we need to first explain cross compilation. So we need to explain how our toolchain works, what a toolchain would do. So the most difficult part is the cross compilation part. Okay, it's not the Canadian compilation part. All the Canadian also have issues, but nowadays they have more bugs and then cross. And a lot of issues, but first we need to explain cross. So we need three parts for cross compilation. One is being used as GDB. The other is GCC. Oh, we just cloned here because I've said it provides AR, LD, whatever. We also need GCC itself because GCC provides the compiler itself, the compiler supporting library. For example, how to do 128 multiplication, for example. It requires compiler support, right? It requires some library support. That library is libgcc. Also, exception handling, whatever, all sorts of things, they are provided by libgcc. We also need libstd C++, right? Because we need C++ standard library. But that's not enough. We like a crucial part of it, which is libc. Okay, only this example is min GW W64. I'm going to first show this here. If our Linux is using glibc, the libc provides an interface to talk with the operating system kernel. Okay, libc provides the interface for talking with operating system kernel. On our Windows, it's min GW W64. Okay. On Linux, is usually using glibc. But sometimes some other people using muscle or whatever. That's why they have the differentiation on GNU here. If you use GNU, which is glibc, okay. If you see something else like muscle or Android, whatever, it means it targets another different platform. That's different libc, but it's still the same thing here. It's the same kernel, but it's different libc running. Even with the same kernel, with same architecture, if your libc is different, they are different machine. The code cannot compile with each other. Okay, that's very important. Okay, that's very important. Now you might say, what about C++ standard library here? The C++ standard library will just invoke functionalities from libc. Okay, so libc C++ will just call the functionalities from libc to perform the job. Okay, which is basically a library that relies on libc. But it's also very important because without C++ library, you won't get a full cross toolchain. You won't get a full toolchain, then you cannot do Canadian compilation, right? That's why you can see all the operating system will ship you with both libc and C++ library. Even on Windows, it's the way. Okay. So the build process is first we build cross-compile bin utils because we need an IR linker, right? Then we have build across the GCC part. It doesn't build the full GCC because we cannot build that. We need libraries. We just build the GCC part. Then we build BGCC for some reasons. Sometimes you don't need to, but sometimes this part is different. Okay, so since this part is different, okay. GW is very simple. If you're using GW, the trivial things a lot. You just build GW. Then you build libgcc, build libc, and building other libs like Sanitizer, libvtv, whatever. They realize a C++ standard library, right? So this is the entire process. But if you're on some platforms like Linux, we're going to build GCC twice, okay, to get GCC works and build GCC works and build them together. I'm going to explain that later. But first, we're going to do a simple thing to explain here, which is going to build a Windows, build this compiler, build the GCC compiler that running on Windows on the Linux. Okay, this is our first step for doing the things here. But first, please upgrade your native compiler. Okay, native upgrading compiler not only ensures you don't have issues with compilation, but ensures you install all the packages that the system requires. Okay, because if you cannot do cross native compilation, you cannot do cross and Canadian. They all rely on things what native compiler requires. So native compilation is very, very important. So now it's building the libc C++. We're gonna wait. Okay. So this difficulties. First, I'll explain find the fuzzy machine, not recommending Windows using native compilation and not using WSL and WSL2, even WSL virtual machine. Please don't use virtual machine. Okay? Virtual machine doesn't have enough power we need. And we need to fix that. Okay. We're gonna build things with multi-libs here. With multi-libs, we need to tweak things around. It's not quite easy. A lot of bugs in the GCC stuff. With that, we can just building LVM. I'm going to make another video on how to do LVM cross compilation. But even with that, we need to first build our cross compiler GCC. You cannot just have a GCC to compile a client. Okay. Because client doesn't work that way. Okay, client does not work the way you think it works. Okay, it doesn't provide all functionality. It just use the functionality in GCC. Of course, it can be libc access, whatever, but libc access doesn't work as good as libc STCC. So I can just explain to you. So first step, we're going to do this. Okay. This is our first step. Okay. Now we can do lots of other interesting combos like i56, MS-DOS, DJGPP, G++. This will compile DOS programs. Okay, DOS program. Let's for example, I have MS-DOS, DJGPP, G++. I'm gonna have that. So they can all be done by using this process. Okay, you put a G++, and using compile this, then use this to compile them together to do the compiler, right? Oh, here's another thing. Do not do this compilation in NTFS. Okay, because you have similar links, right? It doesn't create similar links, right? You have this name convention because it's case insensitive. So even a file system matters. Please just use a name GCC without any bullshit. Okay, don't put any link to do this thing. Or you can FreeBSD, whatever you want. But I'm going to show that in a minute because most people are really doing their job, and it's the best thing I think. Right? Now I don't have FreeBSD 16.4 installed here. It's all being done by using Canadian compilation. Okay, this compile FreeBSD program. A lot of cross compilation just by doing the process. It's very interesting. Let me do a microphone test to see what my microphones work. Okay, recording. Okay, recording. Video recorder. Video recorder. Oh no, video recorder. Are you working? Test microphone. Microphone. Does my microphone work here? Microphone. Okay, it works. Right. It shows here. So. The sanitizers. A lot of you are now building things with sanitizers. I strongly recommend you for using sanitizers here, because sanitizers ensure you don't have all the problems you had. In compile 3 libraries, right? x86, M64, M32, and MX32, right? That's why it's going to take a lot of time here, even with a very powerful machine, just to compile things for 3 times, because they're for different things, right? You have to combine them 3 times. Right. I think MX32 will probably be the third one. Oh, I think yeah, MX32, right? Lisa. Now, lib sanitizer is provided by LVM, right? It's synchronized from LVM repository. So it's actually using LVM's lib sanitizer here. But GCC also provides that, okay? But it doesn't provide fuzzer. Probably we can, GCC should add fuzzing into them. We've done that. Then we do sudo make install strip j and enter our password. Okay, only Canadian native compilation need enter password. Please don't enter any password after that. Okay, so we've done here. We can just test that by using G++, right? Happy 2022. Or we've done native compilation. If you want to test that, you can just try to write, just try the IO stream, right? Try the hello world, right? Then see out hello world. Please never use sudo. Okay, please never use just do this. Go fast. You can just try 23 because now GCC supports 23, right? Now you can also use Go linker we just built here. Okay, so in a lot of situations you will end up with a problem which is it doesn't link to the correct C++ library. That's why we need to do this. Okay. Okay, nothing wrong here. This is native one. We found that. That will create a second directory, which is cross. We need to first use cross compiler, right? Then, of course, we should also create another directory called Canadian. We also need to use GDB. Okay, well, first you use GDB. No. Put a triplet here, okay? Put triplet. We're gonna first build Windows one, which is x86 Windows here. Because it's simple, okay? It's similar compared to GDBC. GDBC is very hard. I'm gonna show that later, but I'm gonna first explain things easier with the thing here. So we need to do this thing. First, we need to set the prefix here. Prefix would be x86 64 meaning GW32, right? Then we need to set target. Oh no, its target is MS64. Okay. Prefix we need to reset again. It's not here. Okay, this step is wrong. Okay, this is wrong step. Target is this. This is wrong. Okay, this is wrong. So what we do is we're gonna put a directory. What I put is cross. I put all my cross toolchain in this directory here. You can just put anything here. Okay, I will just put home on cross. Okay, home cross and target. Okay, we can just show the target prefix here. Then what we need to do is set path. Okay, put a okay, put separate them with prefix bin. Okay, bin. Okay, just show here path. Since I have already added the thing here, we can just show here, right? We have the XCC6 here. I've already added those things before, so they also have this file. But in basically, if you don't set that in the base.rc, you can just set here in the base.rc if you want to use that permanently as all the commands you need, right? I just put all the cross toolchain I have here. Oh, it doesn't have ARC64. This is wrong. Okay, it's bullshit. We don't have ARC64. There's no such machine here. Okay, we're gonna put all our toolchain here and do this thing here. Add the things to the path. Okay, put bin here because all how the base is going to find where our new cross compiler is located. It cannot, right? It needs to use the cross compiler to do things. That's why we need to put that in the path. So after that, we build bin utils GCC. Okay, this is a little bit different from native compilation, but it's basically the same. Okay, since we are not compiling ELF binary, we're compiling PE binary. Enable Gold, we don't add enable Gold here because Gold only supports ELF. It doesn't support portable executable. It doesn't support PE. And we just do this, right? Disable NLS, disable double error. Target, we just set our target here. Prefix here, right? Let me think with, okay, with Python 3, right? Python 3. All right, I forgot that things again is config. It's not just the directory, right? Let's just see the triplet here. The triplet is showing our using target system is XCC64, W64, right? Please always check the thing here. You can also check whether this is correct by using echo. Okay, I just echo it. Right, it shows the thing we just showed here. Ensure this step is correct. Now we make we build the linker, debugger, assembler, whatever. Okay. I also build DLL to WinRes because that's the thing that is only targeted for Windows here. So it's now using our native compiler to build the cross the linker in the cross toolchain. Okay, in the cross toolchain. Let me check my diff whether it's different. New things I should not check. So don't change those things, okay? I think I shouldn't change those things. I shouldn't too much useless garbage. Just don't do that, okay? These are not things you should do. Nothing to do with that. No GCC, okay, that's fine. That's fine. Okay, we've done that with the install strip here. Okay, now we can just try x86-64 AR version. We can see the version here. We have the today's version, GDB version. Since we are using the master version, we can just try to pull after each build. We might be able to get a new version. Oh yeah, we get a new version. ELF. Is there some bug fix or something like that? Let's just check what thing is adding here. Oh, just define some micros. Doesn't matter. Okay, you don't need to recompile if they upgrade. You just continue. Okay, you don't care about that. Then we build GCC. So we only build the GCC part. We don't build the full GCC here. Okay, we also, just like I said before, of course, if you want to disable bootstrap, you can disable bootstrap. It doesn't matter because when you do cross compilation, it doesn't bootstrap itself. Okay, it cannot bootstrap itself, right? You cannot run the program how it's gonna bootstrap it. It cannot do that. You can bootstrap. I don't care about that. Then we need to set target here. Prefix equals prefix. Then disable lib std c++ verbals, and this with pkg version happy 2022, not 2021. We are entering 2022 here. Okay. Anything missed here? Oh yeah, with language, right? Enable languages, right? Let's just check that with our non-native Toolchain enable languages. Enable multi-lib. Okay. We don't need make multi-lib list because it's going to just using the things we need here. If we want using LVM lib C++, we can add these things here. So what the directory here? So if you're setting that, you set prefix equals target, okay? Then C plus include C++ v1, okay? This is your target, okay? Let me see whether anything is missing here. Okay, check carefully, then check this whether the three triplet are correct. Okay, always check that. So we're not going to build entire GCC. We're going to only build the GCC part by using make all GCC. Okay. Oh, this is something I forgot here. Yeah. You probably need to do that. Okay. So please go download prerequisite if you're going to do that. But if you already installed that on your native machine, you just do this, right? You don't care because your native machine is already installed those packages, IRC, whatever. Let me see. It should install, I think. But don't care. I just make. Oh, no, don't make J. Don't make J. Okay. I forgot that again. If you don't have those things installed, you need to download contrived and download prerequisite, right? No, make our GCC, okay. put a J here. If your machine doesn't have enough power, don't set the version too low. Just a J for whatever. If your machine is very powerful, like this machine, you just make J. So we're building the cross compiler. We just build the cross linker, then we need to build the cross compiler. With the linker and compiler all together, we can build the libc. Okay. I strongly not recommend you for using any auto tool for doing the job. Okay, unless you know what they are doing. You've done that for several times, for example, because it's quite easy to mess up with this build system. You know, just manually do that thing. Yeah. Okay, so in the first step, we build the cross compiler. It's basically done. Now I'm gonna build. Okay. You see, it's using our native toolchain to build things from to the cross compiler. Build our cross compiler here. Oh, I forgot that thing again. That's bullshit. That's bullshit. Yeah. I always forgot that. Okay. Sorry. We have to interrupt the compilation here. Okay, so here's the thing here. We need to disable SJLJ exceptions. We cannot use SJLJ, okay? We need the dwarf, even on 32-bit machine. So this is what you can do on Windows. Or you don't need to do that, probably you're going to do that with some other 32-bit. But disable SJLJ exception, okay? I just forgot that, sorry. Now we'll build that again. I will show that, put that in the comment section. If you have any questions, you can go to the Linux from scratch, right? Linux from scratch, read online. Oh, it also has other versions. Other language version. Um, Let me see what his GCC is installed on. What the fuck? No, this crap is absolute crap. It's not building for cross compiler, right? This is ridiculous. Okay. It's the thing. glibc doesn't work on Windows. Okay, the libc on Windows is MinGW W64. Okay, that's the thing here. Okay, just MinGW. Don't build glibc. Okay, nothing to do with glibc. I'm gonna do it later, but it has nothing to do with Windows. Okay? You just have nothing, zero. A lot of things you need glibc for all platforms. That is wrong. Okay, glibc is completely not required. It only works on is required on Linux. It doesn't work on. It's not required on other platforms. IBM also supports this G. Well, if you think it way too long, now clone Linux kernel. Okay, Linux kernel is also needed. Okay, we'll explain later. Also GDC, clone all of them. Okay, all of them. Should be git switch, right? Switch to branch. Depends on what our platform is, for example. Okay, we already done. We finally finished the compiler part of C++ of GCC. Then we're going to do is make install strip target GCC J. Okay, no, not target. Install strip GCC. Okay, not install strip, but install strip GCC to just install the GCC part across compiler part. Now, if you set your environmental variable correctly, you will not be able to have the compiler. But this compiler cannot produce the binary we need because it doesn't have the library it requires. So in the next step, what we're going to do is we need to compile MinGW. Okay, MinGW64. But MinGW64 needs two steps. First step is to build the headers. So we put the headers here, and then we compile the thing here. Right? Then we need to config, not config, but go to the subdirectory, headers, config. Okay? Here's the difference. You cannot set target here. What we need to set is host equals target. Okay, host equals target. Then we go prefix equals prefix plus target. Okay, prefix slash target. That's the thing we need here. Okay. Then we make j make install strip j. Okay, it install all the headers MinGW requires. So this is the first step. The second step is to build MinGW W64 CRT, right? So we go here, go MinGW W64, go to MinGW W64 CRT config, disable NRS, disable WError, target equals target, host equals target, perfect equals perfect target. Okay. Prefix is here, target is here, and yeah, that's it. Enter. Okay. All right. Okay. I think we better install it to other directory, not here. Some backup directory, put in the backup. Okay, because we're probably going to use it later, even for Canadian. We can just use Canadian's prefix, okay? Canadian, okay? Target. Of course, we need to put it here, right? Because it's the target, okay? No, if Canadian is native, we need to just put backup here. Just put here. Just put Canadian here. Just directly install Canadian, so we don't need to install that again later. Okay. If I know correctly, if we just do that, we will probably get bugs. We will likely to get compilation bugs with it. Okay, because I'm going to show you the bug here. Okay, just show what's happening here. From my experience, we're going to enter bug here. Did I just clone MinGW W64 here? Oh, I didn't. That's bullshit. Let's see, we finished here. This should show no directory, right? It's quite funny, right? The reason we have this bug is because it's quite funny. This bug is quite funny, okay? It's because of that. It's simply because we did not, we set too many threads that build here. They just set 6 threads. Don't set too many threads. Okay. It's quite funny. They have this bug. If you build with a lot of DLLs, they probably could. They gonna overwrite files with each other. Then you can enter the problem with it. They probably lack of testing here. File truncated. Error reading. Oh, these things make me mad. This absolutely makes me mad. I think it's absolutely because just too many threads as a problem. Let's just fill a thread. Okay. If it's still a problem, I'm going to just report bugs. I think it's probably a bug. Mm. How many COVID today? All right. Wow. Sorry. God. What a joke. This is a joke, right? Wow. Okay, we're finally done. Now we go to make install strip J4. Okay. Great. We finally directly install this thing here. Then we can copy that from the Canadian compiler itself. Because we haven't installed anything on the Canadian compiler, you just treat it as an empty directory. But here's something what you can do. Now, if you don't bother, you can just build that again, put in the prefix. Okay. I think it should not ask us to recompile it again, right? It shouldn't. Great. Make install J. Okay. Install all the thing here. Back to cross compiler. We need to install twice. One for Canadian, one for cross. Okay. So we go to x86-64. So here's the thing: we cannot just continue, because here's a weird bug in the GCC is that we will not be able to find lib32. So to fix this bug, we need to do is that we need to copy lib32 to another directory called 32. Okay, then we move this 32 to the lib directory. Okay, so in the lib directory now we have 32 here. Now you'll be able to find it, because now it's going to find the libs in the 32 here. We need to copy that to the directory. Okay, we've done that. We go back to GCC part. We continue make J. Okay, now it's start to build libgcc and C++ standard library with this thing here. The wolf, right? The wolf. After we compile that, we can just delete this 32 directory. We don't need that anymore, okay? We don't need a 32 directory anymore. You can leave it here if you don't care. If you want to just upgrade in the future, probably need that. But I don't. I think we just delete 32 directory. Okay. Hello. I find that it is not quite easy for Windows to test The microphone on. Okay, no problem. Okay, it's done. Okay. Install strip J. Okay. So we can test that by writing another IO stream, right, to see whether it works on Windows. Okay. You will find that it cannot find DLL, right? So, okay, the correct way to run this on Windows is that now it's not G++ anymore. It's the prefix G++. Okay. A.cc. Okay, so here's the thing here. First, we delete this 32 directory. We don't need that anymore. And in this lib directory, okay, in this lib directory, we have the DLLs we need. All right, Windows want DLL, so we need to copy this DLL back and set them in the environmental variables. Then we'll be able to run that, or we just shift the DLL with our application. We'll be able to do that. All you can do is running that with static. If you're using wine also allow you to add that in the registry. I'm going to just show that in wine here. We're going to run the programs in wine. Okay, you can also run on Windows, no problem. But we're going to show it later. So now we're going to start the step with Canadian compilation. So to the Canadian compilation, the first thing we need to do is that, so other than before, we just do the cross part. Okay, this license bullshit. It's just this crappy Toolchain. Don't install this garbage. Okay. README. This is crap. This is absolute crap. What's CD? Okay. So we need to install. If you don't need GDB, if you don't need GDB, you can just not do that. But if you want GDB, you need to clone a GDB version. You need to install a GMP version. We're gonna just download GMP here. But I find that if we GMP, which is GNU multi-precision library. You only need GNU multi-precision. You don't need MPFR. Okay, you need this GNU multi-precision library. Then we install this. Okay. Whatever. Okay, we just assume you have unzipped that. We're gonna compile it. Okay, we'll go to our Canadian. The first thing we need to do is actually doing cross compilation to the GMP or the GMP library. No, go to GMP. Okay, go config, disable ARS, disable. What I did is coming from a GitHub repository. You can install step then with disable whatever. Prefix is still the prefix we just set here, but host is target, right? Because for this, that's the thing how it works. We need to install a no. Don't forget it's this, okay? Okay, it's this. Oh yeah, it says, okay? Is this the problem? Okay. Show here. Build, oh, it shows our CPU here with Ryzen. Make the GMP library. Install strict, okay? Then we're gonna go back to being used to GDB. Go to GCC. Okay, let's just do that one step by step. Go to the GCC view, create a directory called Canadian. Then create another directory called our whatever we want. We're gonna just create another directory, which is we can just show that with native, okay? Whatever. Which means it's host on this platform, but it's a native Toolchain. Okay, you can just call it itself, doesn't matter. So now we're going to show is that we're gonna add a host prefix here. A host prefix is our Canadian, the installation path of our Canadian Toolchain, right? We just set here. No, it's here, right? Disable NLS, disable WL. Okay. Don't set Python 3. We don't have Python installed, right? So don't set Python here. NLS, WL. Then, okay, we're going to just show whether we have GMP here. No, leave GMP. Yeah, we have GMP, no problem. No need editable go target host equals target is still target, right? Then prefix is the new host prefix we just said. It's not the original prefix, it's a host prefix. So do that. Okay, now you check we have the cross compiler. We're going to use our cross compiler to compile the linker. Okay. Okay, so the second is of course GCC part. We're nearly finished, right? But here's something we have to manually tweak: is that there's several bugs with Canadian compilation, right? That's why I'm saying difficulties here. Now the first bug is the no std in C++. We need to set this row cxx. You just search row cxx equals what? It will give it's wrong. Okay, it's no std in C++. I've submitted patches. You can go there here, see fenv.h. This is a fenv.h. Okay, this is Bugzilla. If you want to see, here's a bug here. Bug 1. Okay, bug 1. Is this bug? Okay, aggression. Okay, so here's the first bug. Okay, is that it won't search correctly for the fenv here. Okay, we install. So the first bug that's the first bug we need to fix. And second bug is that it will copy the wrong DLL. Okay, copy the wrong DLLs. That's the second bug we have to fix. Okay. Basically, all the library you need to build, we will all need to fix all the bugs here. Like if we go to libcodemath, for example, I've already fixed that. We need to search the sigwin here. Sigwin, okay. So, okay, it's this whole crap part. Okay, it's crap. It will copy the wrong DLL since we're compiling multi-libs, right? It will assume that we're running in a bin, right? But when you have 32 and 64, they copy together. Since 64 bits DLL will first be copied to the bin, then the 32 bit will be copied again to the bin. Then the DLLs override each other, right? That's wrong. So to fix this bug, okay, we need to go to this whole thing here and change it with a multilib. Okay, change it with a multilib. I think I should just find a patch to GCC itself instead of letting us to fix it, because it's clearly wrong. It's just wrong here. Go to the library spec. Okay. Just copy the entire directory here. Okay, so change this to this part. Okay, change it to this part. I've already done that. You can see it's already a commit change here. Okay, we need to set a multilib and fix it. It's not just fix it once. I found that in libc to C++, it has two of those things. Yeah. Okay, you have two. We have two. Okay, so we need to copy this for twice. Okay, copy this for twice. Okay, so it's generated by the libtool, and the libtool is just doing the wrong thing here. Okay, it doesn't understand what we are doing. It's multilib, VTV, libatomic, all the libraries. Even using gfortune, if you want to using fortune, you must do this. Okay, you must do this. Let me see whether libvtv or libssp, whatever, all the DLL are doing the thing right. Okay, I've already copied that. But since libc to C++, the config file is frequently changed, we have to add the thing here. So we compiled the bin utils. I think we've already installed the bin utils, right? We can go and check in the Canadian to see whether the executable file, the exe file, has been rebuilt. Yeah, we have all the Windows file because it's .exe, right? So the next step, we're going to build GCC. Okay, so what we're gonna do is that we need to copy the build script from from the cross compiler. Okay, then replace all the Canadian with this, plus add a host. Okay, host is what the Toolchain is hosting, just like Bing use, right? We put that here, and plus enter. Okay, here's something which is incorrect. Okay, it's directly in Toolchain here. It's not in the subdirectory. Okay, there's the difference between native and this will be the native Toolchain. It's installed here. It's not installed the directory inside the directory. Okay. 1, 2, 3, 4, 5. It's five levels of parent directory, right? Then we do this. Let us just check whether build host target are correct. Yes, but it cannot find GMP, right? The reason it cannot find GMP is because we did not do this. Okay, we need to go to the contry download prerequisite. I just press pause. Let's see whether it gets upgraded. No problem. Okay, failed. It doesn't match. So we directory again. Just delete it again. We delete and recompile it. It doesn't matter. Now we should be able to do this. Okay, that will make J, or it doesn't care, just completely make J. You don't need to do that thing here. We have already compiled everything we need. Okay. This is Windows-specific issues with GCC. If you're Canadian compile to other platforms, you don't care about that. Okay. Yeah, you can see we're using cross compiler to compile GCC, right? Oh no, it. seg4. You can ignore this part if you don't want to change that. You can just build all GCC and all target leave GCC. Then you're finished. Then copy all the DLLs or whatever, all the libraries from cross compiler. It also works. Okay. It doesn't matter if you don't need, right. But I'm just gonna show you the full process here, full progress here. Okay, this is really a full progress, and we don't need to do anything. Just let the GC deal the compilation script do the things itself. Mm. Mm. Oh. Now we make install strip J. Okay, so we go back to Canadian, right? We just installed in the Canadian directory. What is this? Okay, I think I have previously installed. Just do that. Okay. So we have this installation in here, right? Don't copy. Although we have the compiler, we cannot just copy this from Linux to Windows because you might have similar link issues that is not good. Okay, so we do cvf. Okay, I think it should be this. No, quite the opposite. Okay, so we compact this to a tar file, right? Now we have a tar file. Now we copy that to a directory. For example, here, I think the already installed just for coverage. Okay, so then what are we gonna do? So you need to ensure you have 7-zip installed. Then we're gonna run 7-zip with administrator, run as administrator. Or you cannot understand similarly. Okay, go to similar link. Okay, I'm going to just override all file. Okay, just delete it. So if you just directly do this delete file, it will be very, very slow. We can just delete that in here. Okay, it will be very fast. Okay, because File Explorer is running a very performance bad way. Okay. Right, we've done. Let's just check that. All right. So how to use it? Okay. So we need to set environmental variable in the path. We need to set 3 things. So first, set this directory in the directory. Also, we need lib and lib32. I think I did not set lib32 here probably. I'll have another installation. So we need to set lib and lib32 into the path. Because the reason you set bin is that, of course, the compiler is installed bin here. But you also need to set lib here, is that lib std++, and all sorts of other DLLs, C++ standard library, is installed in the lib directory, right? So this is our C++ standard library here. Now we can try whether now all things are set, right? We create a hello world. Okay, well, just a lot of crap here. Let me just try include IO stream, right? This is on Windows, okay? We've already built a compiler for Windows, okay? So how to compile it? A lot of you just don't know. You know, the correct way is just to command CMD. We get our command line here. Then we compile it with hello. We can do whatever we want. That's like we do in Linux. Oh, it can show double char. Do you know why? I think that's something I missed here. Okay, probably we did not install the headers. It requires. So when you install the headers, okay, no headers, right? No headers. So we lack one piece, which is headers, right? It just install the runtime, doesn't install headers, which is quite ridiculous. Go back here, I'm gonna install headers. Okay, just go to Canadian and compile it. It doesn't matter. It just doesn't matter. You just can set whatever you want. A home is this, okay? So this is something you need to ensure. Install here, okay? Because we did not set up environment variable, right? You can set it with manually in that file, but you probably not set. Now go to imaging ww64 headers. Config, disable ARS, disable WArrow, host, okay, host. Prefix. Right? Then we compile it. Done. Now try it again. All right. Just the headers takes 60 megabytes. Ensure we are running as administrator, as administrator privilege. Yeah, now it should work, right? Yeah, no problem. Okay, so this is the first part. Probably take a lot of time. Then we're gonna compile Linux. Probably not going to finish in this video because this video has time requirements. Okay, let's just stop here, and I'm going to do that in the second video. Okay, so this part is just compile Windows, right?